Hi friends, welcome to GradeUp, India's largest e-learning platform. In this session, we are going to concentrate on Good morning, Twinkle. Vamsi, good morning. Is audio and video is clear to all of you? Is audio and video is clear? Good. Vishal, Shaket, good morning to all. 1 second. Now. Yeah, good. In today's lecture, we are going to concentrate on other curves, because yesterday itself I said there are 4 types of curves we can able to come across in drawing. Sir, which line is used for special features of the surface? Thick chain line. Thick chain line. So, who asked? Sanket, the answer is thick chain line. I will show how it is going to be. This is for special features, but this one is a chain line. That is the difference. This is for this is a special features. This is a chain line which is used for axis. This is the difference between these two, my dear friends. Is it clear now? No. I have to rectify. We will rectify, my dear friends. Double dotted chain line will be used for flexible elements. For flexible elements only double dotted chain line will be used. But we won't use thick chain line, because special features only we can able to use for thick chain lines. I hope in the last before class with the actual machine diagram itself I shown. I will ask them to correct it. Now, in this lecture, we are going to concentrate on cycloids, involutes, spirals, and helix. Sir, what are the various curves we can able to come across? In the last class itself, I said these are the types. One is conics. Second one is okay. I will check it out. What is the problem with that? I will verify, my dear friends. Conics. Second one is rowlets. Third one is spirals and helix. And fourth one is Voge curve. I hope all these are over to you, because first and fourth one is over. Fourth one is very simple. It is a combination of convex and concave shapes. The best example is a sine curve. Yes, we can able to observe this type of structures in the various masjid or some other places. So this is nothing but Voge curve. Conic sections we are already come across in the last class. Now the remaining are rowlets and spirals, because sir, you are using the word rowlets and spirals, but rowlets you are using, nowhere you are mentioned cycloids and involutes. Where it is? Because in the heading itself you shown it as a cycloids and involute. Good morning, Sini. but where it is. So remember, my dear friends, involutes are divided into two categories. One is cycloidal curves. Another one is involutes. Is it clear to all of you, my dear friends? So I'll give in detail of this in this lecture. Now here, if you observe, before moving on to the element, first of all you observe this. All of you observe this curve, my dear friends. From this I can able to give the definition. Now here you observe. Now here there are two curves are there. One is a blue curve, another one is green curve. So just now you observe blue curve is not changing its position, but whereas green curve is changing its position. Just you observe. Now whenever the green curve is moving, here I am considering the black color is going to be the point on the green curve. Whenever the green curve rolls on a blue curve, we are getting the path like this. So this is going to be the red color curve line is going to be what it is. The red color one, what it is called. So here you remember few terms I am going to place it here. First one is blue color. It is a fixed curve. And what about the green color curve, sir? It is a rolling curve. So what we are consider this is the point on the rolling curve. Point on the rolling curve. Now what about this red color one? This is called roulette. Sir, now can I give the definition of roulette now? What is the definition of a roulette? What is the definition of a roulette? So if you observe, this is the locus. So it is the various locations of the point on a rolling curve. Various locations of a point on the rolling curve when it rolls over another curve. First of all, I will write the definition. Just to observe, later I will give the answer for this. So first of all, I will try to type it instead of writing it. It is better to type it. Okay, I will type it here. Just to observe. It is the locus of a point. So here how the point is, it is a locus of a point on a rolling curve when it rolls over another fixed curve. So it is a locus of a point on a rolling curve. So this is the we are going to get the locus of a point on the rolling curve. So here when it rolls over another fixed curve, here the fixed curve is a blue color one. Is it clear? Up to now you tell me, my dear friends. Now I will give the further explanation to you. So what is a roulette? Roulette is the locus of a point on a rolling curve. When it means the rolling, whenever the curve is rolling over another curve. Whenever it is rolling over another curve. So is it clear? Now here I will give the entire classification now. First of all, you observe Sir, what is this fixed curve, sir? So we will assume fixed curve radius. Fixed curve radius is a capital R. Rolling curve radius is considered as small r. Rolling curve radius is considered as small r. Is it clear to all of you, my dear friends? So depending upon the relation between these two, and one more thing, this is considered as a point P. So the locus, the point for which we are considering the locus, the point for which we are taking the locus is considered as a point is P. So depending upon these three, P is the point on a rolling curve. So what is the another one you have to remember? P is the point on a rolling curve. So depending upon these three parameters, we have different classifications, sir. So this classification is most important. Remember, my dear friends, this one is not available in any of the textbook. I can able to guarantee that, because by consolidating everything, I am giving this particular classification. All of you carefully follow these. So rollets are broadly classified into two categories depending upon based on. So it is broadly classified into two categories based on which parameter you are classified, sir? You have a doubt on what parameter you are classified. So the classification is done based on with respect to the radius of a rolling curve. That is nothing but small r. So here, if small r is not equal to infinity, and if small r is equal to infinity, what they are called? Now tell me. So anybody have the idea, sir? So what is meant by radius is infinity, not equal to infinity? That you have to know. So if r is not equal to, so radius, not r, in general, radius is not equal to infinity is given, means in this case I am considering circle. So if radius is equal to infinity was given, it is going to be a straight line. It is going to be a straight line. My dear friends, wherever you will get the doubt in this particular topic, try to raise it here itself. I will try to give the answers to you, because in the undergraduation engineering point of view, you are coming across how to draw that curve. But here, how to draw the curve is not important, but what is the concept behind it, and what are the various points we can able to get it in the examinations are important. So far we got 2 questions from this in a span of three exams, in 3 exams only. So try to concentrate much here, because there is a ample of scope present to get the questions from here. Good. Now let us consider, I hope you understood. Now let us consider, if the radius small r I am considering, small r is equal to infinity, means it is a straight line, sir. It is a straight line. Is rolling. Whereas in this case, circle is rolling. That is the difference between these two. Sir, whenever the circle is rolling on another object, then what type of curves they are called? They are called cycloidal curves. It is not cycloid simply, it is cycloidal curves. Okay. Now whenever the radius is infinity, means a straight line is moving around it, then it is called involute. Why it is called involute? Infinite radius curve is, volute means rotating. So if the infinite radius object is rotating, then the path traced out by it is called involute. Then the path traced out by it is called involute. Let us consider, my dear friends, this particular thing. So it is a circular object, it is fixed, but you have tried to observe this particular location. So or otherwise here some white color thing is there at the end. Just you observe this. Now whenever it is rolling, what happened? It is coming and moving towards the center. So normally whenever it is a involute, most of the times in the institutions or colleges, we will consider like this. How it is, sir? A string is wounded around the object, circular object. Now if you are unwounded this, then the path traced out by the free end of the line is considered as the involute. Am I right or not? So involute will be defined as two cases. A straight line is rolling over it, wounded or unwounded. So why you said it is a straight line, but why you are considered as a y? So whenever you are, in order to get the locus, whenever you are getting this particular point, from here to touching point, it is a straight line. You observe, my dear friends, unstretched object only can able to give the involute. Is it clear to all of you? So what is an involute? It is the path traced out by a point on a straight line when it rolls over another curve. When it rolls over another curve is called involute. So that other curve may be a circle or it may be a polygon also. How it is, sir? Let us consider. So this is a hexagon. If a void is wounded around it or unwounded from it, so let us consider. This is a hexagon, sir. So in this case also, this is considered as involute. Is it clear? Either wounded or unwounded. In both the cases, it can be considered as involute. Is it clear to all of you, my dear friends? So here, what is, Suhana, I am observing you first time, my dear friend. No problem, I will explain. Don't worry, I will explain to you. Now here you observe. Let us consider. This is a line. So for you, this point is a different color. Just you observe, my dear. Here. Now whenever it is rolling over another curve. So here, this circular one is a fixed curve. Let us consider. Now you observe, whenever it is rolling over it, in the beginning it is away, sir. Now whenever it is coming, it is moving towards it. Or otherwise, reverse, whenever it is moving like this, it can able to move away. I will show with the animation, you can able to get a better idea. And apart from this, there is no need to roll on a circular set. Actually, this is a hexagonal shape. Or otherwise. So this is a hexagonal shape. So if it is rolling over it, so observe. So from here to here, next this, like this. So then the path traced out by the free end is called involute. Either it is wounded or unwounded. So I will show with a animation that you can able to give some more idea to you. So let us consider. Now you observe, my dear friend, the wire is unwounded. Actually, it is a wire is unwounded from a circular disc. Then whatever the path traced out by a point at the end of this wire is considered as the involute. Now you observe. So whenever it is unwounded, the free end only we are observing. So then the path traced out by it is called involute. So some people will have a doubt. Sir, it look like a spiral, but what is the difference between these? So once if I complete spiral also, you can able to know the difference between involute and spiral. So now it is clear, my dear friend. So what is involute? Is the path traced out by a point on a straight line when it rolls over another curve. Rolls over another curve is called involute. Is it clear? Is it clear, my dear friends? It is the path traced out by a point on a curve, on a straight line when it rolls over another curve is called an involute. Okay. Now, okay, sir, this is about involute. Sir, what about the other one? Cycloidal curves. What is cycloidal curves, sir? Anybody, sir? Just now I said. So, if the rolling object is a circle, sir, but where it rolls, depending upon that, again it divided it into two categories, sir. So depending upon where it rolls, it is divided into two categories. With respect to the radius of the fixed curve, that is called capital R. Sir, if capital R is not equal to infinity, if capital R is equal to infinity. So here you observe capital R, I am drawing it as a blue color. In this case, it is a blue color. So green color is related to the rolling. Blue one is related to the fixed curve in this case. So, sir, here why you are after dividing it? So whenever it is R equal to infinity, only one type of curves will be there. Whenever R is not equal to infinity, if it is a circle, again it is divided into two categories. So why, sir? First of all, I will explain why they are divided into two categories. If R is not equal to infinity, if R is equal to infinity, why they are not divided? We will check it out. Sir, let us consider it is a straight line and fixed curve we will consider, because fixed curve we have to consider as a blue. Now, rolling circle, we are going to consider it as a small r. So I am assuming this is a rolling circle. So if it is rolling on a straight line and sir, here what happened? If it rolls over another circle outside, because it is outside this curve or outside of the line, one side of this line. Now, one second, my dear friends. Now, sir, why it has to roll outside? It can able to roll inside also. So once if it is rolls inside, what is the nature of the curve? We are going to check it out. Sir, once this is the curve, Now what I have to do? Sir, let us consider it rolls outside or inside. Sir, whenever it is rolling outside, we will check it out what happened. After half revolution, let us consider it reaches to this position. After one revolution, it reaches to this position. So similarly, in this case, after half revolution, it will be here. One revolution, it will be here. If it is inside, it is going to be like this. So here also, if it is in inside this curve, we are going to get like this. Now if you trace the path of this particular point P, so I am going to consider this point P. After half revolution it is here, after one revolution it is here. Similarly, these are the various positions of the point. Now here this is P, this is P here, again it is P here, here P. So if you draw outside, you are going to get the curve like this. If it is inside, the curve is like this. Now outside curve and inside curve are not same. They are looking little bit different. So whereas in this case, this is the curve outside and this is the curve related to the if the rolling circle rolls one side of it and another side of the straight line. Now if you observe, if it rolls outside or inside, these two curve natures we are getting it as same. That's why only one side is considered. Only one side will be considered. Whereas here, if it rolls outside, we are getting one nature of the curve. If it rolls inside, we are getting the another nature of the curve. Means the curve shape is going to be changes. That's why whenever it rolls outside the circle, outside the fixed circle, then it is called. Anybody can able to give what is the name of this? If a circle rolls outside a fixed circle, then the curve, the path generated by a point P is called which type of it? Anyone? Try to answer, because whatever you know, I can able to know it. If you are not aware of it, not a problem. If you know it, you try to recall your first year classes. Yes. Perfect, Yadav. So it is going to be AP. It is considered as AP. Okay, cycloid I will give again Siri. Exact word is AP. Epic or AP. Sir, if it rolls inside, then what it is called? Excellent. Try to give quickly, then it is very easy for us. When it rolls inside, then what it is called? Excellent, Shivangi. That is, it is called a hypo. This is called hypo. Good, nice. Shivangi, are you from which college? And Siri also from which college? And today I observed only one person new, Suhana. Suhana, are you from which college and which branch? Now here, sir, that is why we are going to get different words here. This is called AP. This is called AP. I am not giving the word cycloid so far. This is called hypo. Sir, what about the cycloid? So far you are not given cycloid. Am I right or not? So far you are not given the word AKTU. Which this university from which place? SIT. Siri from KL. Good. Shivangi Yadav is. I can't able to understand SIT. Allahabad. Okay. KL University, Hyderabad, or where it is in Andhra side? Vijayawada is also there one. That's why. Okay. Guntur and Vijayawada. Nice. Now this is epi and hypo. Now let us consider, sir, up to now you are not used the word cycloid. Why, sir? I'll give my dear friends. Again, Andhra, okay. So now let us consider, why, sir? Because let us consider this is a circle which is rolling. So therefore its radius is smaller, sir. Its radius is smaller. Let us consider this is the center of the curvature. And we are going to consider point P. We are going to observe a point whose locus we are going to get it. So that's why that point I am assuming it as P. Therefore, if all of you observe, if CP is equal to small r, means if a point on the circumference of the circle, they are called cycloids. Not cycloid, cycloids. Okay, I will come to this one here. Let us consider in this case. So if you are going to consider the point on the curve, if CP is equal to smaller, in the first case it is called cycloid. In this case, how the nature is going to be? It is a fixed curve of radius infinity, and rolling curve we have to consider as this is the center, and you are considering a point on the circumference of the circle. Then it is called a cycloid. Sir, what about the another one? So this is point P. So this is considered, path is considered as cycloid. What about the other one, sir? Let us consider the fixed curve is a circle. The rolling curve is also a circle, but it rolls outside. This is the center. And you are considering a point on the circumference of the circle P. Then it is called a cycloid. Understood? Sir, if you are going to consider a point on the circumference of the circle, it is cycloids. If the circle is rolls on a straight line, simply without any prefix, we will give it as cycloid. So if it rolls outside and you are considering a point on the circumference, it is epicycloid. Sir, what about the third one? Let us consider, this is a fixed curve, sir. This is a fixed curve, and a curve is rolling inside. This is a rolling curve. This is the center. If it rolls inside, then the path traced out by a point on the circumference is called hypocycloid. Is it clear? Sir, okay, sir, if the point on the circumference of the circle, you are saying it as a cycloids. So I am going to write the word as cycloids. Cycloids means simply, if it is rolls on a straight line, simply it is called cycloid. If it rolls outside, it is epicycloid. If it rolls inside, it is called hypocycloid. Sir, let us consider if the point is not inside, sir, whether it is outside. Let us consider these two cases. This is P1, CP1. So this is my second case. And if it is third one is a third case, P3. Sir, if CP is not equal to small r, then what it is called? Anybody have the idea? If you are not considering the point on the circumference of a circle, if you are not going to consider the point on the circumference of a circle, then what curve it is called? Anyone? So once if you try like this, then only it is easy for you, my dear friends. You can able to remember forever. Okay, yes, perfect, Siri. trochoid. My God, Siri, you said you belongs to ECE, still even better than mechanical and civil people you are giving the answers, because for them only we will get these things. Okay, trochoid. Nice. Good, Siri. Now, here, sir, here you said one thing. That is, if CP, trochoid means if CP is not equal to R. There are two possibilities are there, sir. There are two possibilities. That is, if CP is greater than small r, means it is outside. It is outside the circumference of the circle. Sorry. It is outside the circumference of the circle. Then it is called superior trochoid. And if it is CP is less than small r, is it inside, then it is called okay. Twinkle is asking one question. Is it correct? Are you attempted this particular 2019? Now it is called inferior. Even I have the doubt. I have the same doubt as Siri, because in undergraduation even I took this particular subject for so many batches. Normally up to this depth I won't give in the colleges, because even we won't go ahead with practicing of all these things. That is, so this is called superior trochoids. This is called inferior trochoids. Yeah, good, nice. But remember, all these concepts is very nice. Now let us consider what are the various names, sir. So I am going to draw the diagrams first, then we can able to proceed to the various elements again. So it is a straight line. Okay, so fixed circle. Now we are going to consider it is a rolling circle. It rolls outside. It is also rolling outside. It rolls inside. Inside. But in the first case, we are going to consider the point away from this. This is the center. I am considering the point here. This is the center. I am considering the point here. Because here it is C. CP is greater than R. This is the center. I am considering the point here. Now, what it is called? Superior trochoid. That's all. Trochoids means all these three will come. So this is superior trochoid. So what is the nature of this curve? This is called superior trochoid. This is a superior trochoid. Sir, what is the nature, sir? So first of all, I will consider the nature of the nature of the curve we will discuss later, because you will get the clarity where the difference will come. So in this case, this is the center. I am considering the point inside. I am considering the point inside. Here also point is inside. This is the center. Now what is the, here it is called inferior trochoid. Siri, where you took the any coaching at any place, or you learned from the textbooks? And this is going to be inferior epitrochoid, MTech, nice. Then Siri, it is great. Even though if you are not taking the coaching, you are giving the answers. It is very great. So this is inferior hypotrochoid, due to the space constraint I can't able to write legibly. Just try to understand it, sir. All of you now all of you observe how the nature of the curve will be. If it is a cycloid, I am going to draw a little bit thick, that will be easy to you. So the cycloid will be like this. Superior cycloid is going to move it as a hook like this. Now here it is a little bit flat. Again it is going to be a curve, come like this. It is nothing but a bell shape. So you can able to observe the bell shape is going to be like this. The bell is going to be like this. It is going to be a little bit flat here. Then the curvature like this. So it is a bell shape we are going to get. Okay, here also the same. This is going to be epicycloid. Superior like this. Inferior. So here it is down and it is like this. It is a sharp V type we will get. Here it is a hook type we will get. Here it is a flat we will get. That is the three differences you have to observe for these three. Hypo. So this is going to be like this. Here it is going to be flat you are going to get. So all these things I can able to show with the help of a diagrams. You can able to get some more clarity. Now all of you remember from these what are the points you have to remember. That I will explain once again. All of you remember, my dear friends. First one, rollets means two types. Rollets means two types. If the rolling object radius, is infinity, it is called involute. It is called involute. Is it clear, my dear friends? This is called involute. Now, if the rolling curve radius is not equal to infinity, they are called cycloidal curves. But depending upon the radius of the fixed curve, it is further divided into two categories. Sir, one is if r is equal to not equal to infinity, there are two types. If it rolls outside epi, inside hypo. If it is a infinity, without prefix we can able to give the word. Without prefix we can able to give the word. Another one is if you are considering point on the circumference of the circle. If you are considering point on the circumference of the circle, they are called cycloids. Cycloids. If it is outside, superior trochoid. If it is not, point is not on the circumference of the circle, it is called trochoid. If it is outside, then it is called superior trochoid. If the point is inside, then it is called inferior trochoid. Is it clear? Yeah, I will explain, Vishal, not a problem. So, no, Shivangi, remember, there is no need to roll on a circle. There is no need to roll on a circle. I will show, my dear friend. Let us consider. You observe. Is this cross section is almost a square or not? This cross section is almost a square. So let us consider a straight line or a wire is wounded. Now in this case you observe, this is the, my God, now you observe this particular knob only. Now once if it is rolled like this, then like this is also called involute. This is also called involute. It rolls an another curve. If the other curve radius is not equal to infinity, it is rolling on a circle. If other curve radius is infinity, it is a combination of the lines, that is called polygon. It may roll over the polygon or it may roll over the straight line. Both are considered. Both are considered, but both the names will be involute, because here it is not based on the fixed curve. It is based on the rolling curve. Rolling curve radius is infinity. That's why first two words in and rolling. What are the other words we are going for? Rolling, rotating, rolling, volute. So that's why from the volute, from the word revolving, they consider volute. So that's why together is called involute. So it may rolls over a circle or it may rolls over another polygon. Maybe all are considered as involutes. Is it clear, my dear friends? Now let us consider your doubt, Vishal. I will explain that to you. Now you observe. Remember, this is a circle rolling, sir. This is the center C. The rolling circle radius is smaller. Therefore, if you are going to consider a point on the circumference of the circle, if CP or CP1 is equal to smaller, this is called cycloid. Sir, if the point is not on the circumference of a circle, not equal to R, it may be greater P2, less P3. These are the points we are considering. Sir, if CP2 is greater than smaller, then it is called outside. Then it is outside the rolling circle. Outside the rolling circle, then it is called superior. But whenever it is not equal to R, then it is called trochoid. Therefore, if it is outside, superior, trochoid. If it is inside, if CP is less than small r, if CP is less than small r, this is called inferior trochoid. Now it is clear? Good. Now I will show some diagram. I am going to place the numbering. You have to type the what it is. So I am going to place them. You try to give the answers to them. All of you observe, you can able to get the idea. I will play all these. You try to give the answers, my dear friends. I need the answers for these. First, second, third. Sir, can I can't? Yeah, definitely, my dear friends, not at all a problem. At any point of time, you may contact me. I'll give my details, don't worry. Not a problem. Just you have a contact with your friends as well as your faculty. You can able to get much benefit from that. Okay, I will give at the end of after completing these diagrams. I will give you, my dear friend. Now try to type it here. Anyone? A 1, 2, 3. What are the answers? My God. What is the answer? First one is which curve? Second one is what curve? Third one is which curve? Maybe typing it will take time. I will accept it. No. Normally, a little bit, not a problem, but comfortable, not a problem. Inferior trochoid is my dear Vishal, just you observe and tell me. Inferior trochoid answer is there, but it is not for first. It is not for first. All of you observe where it rolls. Blue color and red color is a path. No. So, yes, Twinkle and who gave the other one? Atul. First one is cycloid. I will accept it. Because this is rolling on a straight line and the point you are considering on the circumference of the circle. Cycloid. First one is cycloid. Correct. Vishal, now you are correct. Siri also correct. Second and third. Second and third. Quickly. You want the videos to play again? I can able to play it. Third one. One second. This one I will explain. Don't worry. Sir, here the point on the circumference. Point on the circumference. Therefore, you have to write cycloid. But if it rolls inside, it is rolls inside. Therefore, it is a hypo. It is a hypocycloid. Sir, here the point is not on the circumference. Therefore, it is trochoid. Sir, if it rolls outside, epi. But the point is inside, inferior. Inferior epitrochoid. Inferior epitrochoid. Second one is hypocycloid, correct. Third one is epi, Twinkle, correct. But inferior epitrochoid. Inferior epitrochoid. Good, nice. Now next one you have to give very quickly. So remember, I am going to consider, I am giving the numbers. This is 4, 5, 6. I am going to play the videos again, you observe. This one. Fourth one is this. Fifth one. Sixth one. Sir, third one is superior trochoid. Okay, I will come again, Vishal, don't worry. Atul, what they gave? Superior epitrochoid. Excellent, excellent. The point is outside. The point is outside. Therefore, it is trochoid. But the point is, if the it is rolling outside epi. But point is beyond the circumference of the circle. Therefore, superior. Excellent, my dear. Fourth one is correct. Superior epitrochoid. Perfect, Twinkle and Atul. Vishal, I will come to your answer again. Don't worry. Siri, also you are correct. Next, fifth one. Fifth one and sixth. Fifth and sixth. Fifth one. Excellent, Twinkle. Sir, actually the point is not on the circumference. Therefore, trochoid. Rolls because the point is outside. Therefore, superior. But the circle is rolling inside. That's why it is called hypo. Superior hypotrochoid. Very good, my dear. Sixth one, superior. My God. Twinkle, you check it out your answer once again. Fifth one, superior hypotrochoid, correct. Vishal, your answer is also correct. Twinkle, for sixth one you observe. Superior is okay, but it is not cycloid. Cycloid means the point should be on the circumference of the circle. Point should be on the circumference of the circle, but it is not on the circumference of the circle. It is beyond the circumference of the circle. Therefore, it is superior trochoid. Excellent. So, this is going to be considered as a superior trochoid. Yes, that is correct. Atul, you are correct now. Yes, that is correct, Twinkle. It is not cycloid, just it is a trochoid. Now, I will show few more. You try to give the answers to them also. So here I need the answers for I'll play the videos now. Red color and so blue color, you tell me. Blue color. So here I am going to draw two things, sir. Blue color, what type of curve it is? Red color, what type of curve it is? Can you able to give the answers, my dear friends? superior. Okay, one second. Atul, superior is not correct because the point is on the circumference of the circle. Therefore, we have to use the word cycloid. We have to use the word cycloid, but it is rolls outside. Therefore, epicycloid. That's all. Now here, blue color is the point on the circumference of the circle. Therefore, cycloid. But rolls inside, it is hypo. But whereas red, it is a trochoid. But inside, therefore, inferior hypotrochoid. Inferior hypotrochoid. Is it clear to all of you, my dear friends? Twinkle, correct. Blue color one is no, blue one is not a fixed, my dear friend. You got it as a line maybe, but the blue point is also on the circumference of the circle. Shivangi, you are correct. Hypocycloid. Atul, also you are correct. Now, Vishal, you asked one thing. What about the third one? Here you observe, my dear friend. Third one, it is a point inside, therefore inferior trochoid. But it rolls outside, that's why it is called epi. Inferior epitrochoid. Inferior epitrochoid. Is it clear? Eighth one, I will repeat it. I will repeat it, my dear friend. No worry. Now here I am going to play it. Just to observe it. Sir, blue color point and green color points are on the circumference of the circles. Blue and green are the circumference of the circle. Red and sky blue are on the inside the circumference of the circle. Or inside the circumference of the circle. Now you observe. So blue is going to generate a straight line, not a problem. Red is going to generate it as an ellipse, as well as sky blue also ellipse. But whatever the curve, it may be immaterial for me, sir. But if the point on the circumference, if it is the point on the circumference, if the point is on the circumference, cycloid. If it is inside, because this is a diameter line, that strip, whatever it is going to show it as a highlighted, it is a strip. On the end of the strip, red, blue color point is there. Inside the strip, we are going to have red color. Is it clear? Now this is about the thing. Is it clear? Now, the important element, my dear friends, all of you observe. This is also we can able to expect in the examination. This type of things we can able to expect in the examination. That is, sir, if a circle rolls on a straight line, very simple, sir. It is not much typical. Very simple question. Rolls on a straight line. If it rolls for one revolution, directing line length. So here some terminology I am missing, my dear friends. I will give now. Try to excuse me for this, because in the beginning I have to give, I forgot. So here you remember the curve which can able to generate the path of the locus of a path. The rolling curve, it is called rolling circle, or which is also called generating circle. Generating circle. Is it clear? Whereas this thing is called directing curve. Sir, in case of cycloid, this is called directing line. Whereas in this case, it is called directing circle. or fixed circle, because directing curve or fixed curve. So directing circle or fixed circle. These two are the words we are going to use for these. Is it clear? Rolling circle or generating circle. The rolling circle where it rolls. If it is a straight line, it is called directing line or fixed line. If it is rolls outside or inside a directing circle, then it is called fixed circle or directing circle. Okay, my dear friends. Now let us consider one particular case, that is if it is rolls on a straight line for one revolution, how much directing line length is required? How much directing line length is required? If one revolution, how much length is required? If half revolution, how much length is required? If 1.5 revolution, how much directing line length is required? Just to tell me. Because I have to draw the line for how much length. That is important. How we have to know it, sir? Anyone can able to give? So if it is a one revolution, excellent Shivangi. So if it is a one revolution, 2 pi r length is required. If half revolution, pi r, 1.5 revolution, 3 pi r. Okay, sir, I understood. Yeah, Atul, I will repeat. Sir, if a circle rolls for one revolution, if in a cycloid, if the radius of the circle is smaller, and if it rolls for one revolution, how much length of the directing line is required? This is called length. How much length I required? If it is one revolution, 2 pi r, yes, that is correct. If half revolution, pi r. If it is 1.5 revolution, 3 pi r. Good, sir, this is okay. For epi and hypo, for epi and hypo, for epi and hypo. So let us consider, this is the fixed circle, sir, and the circle is rolling either outside or inside, whatever it may be. Both the radiuses I am considering it as same. This is R and this is also R. Then for one revolution, how I have to consider, sir? After one revolution, let us consider it reaches to this position. Means we need this part of the circle only. This angle only is required. This theta is only is required. Then what is the angle? So I am asking the question. The angle made by the angle makes at the center of the a directing circle when generating circle rolls for one revolution. How we have to know it, sir? Very simple, my dear friends. Very simple. How we have to get it? Just I will explain to you. Just you observe. Now here you observe. Sir, once according to the generating circle, if it rolls for one revolution, how much distance it is traveled? 2 pi r. As perfect twinkle, 2 pi r distance according to the generating circle. This length I am going to draw with red. I am going to draw with red. This length according to green, it is going to be, according to green, it is going to be 2 pi r. According to blue color, directing circle, what is this length, sir? It is nothing but radius of the directing circle, multiplied by the angle made at the center. Length of the arc is equal to r theta. L is equal to r theta. From that particular thing, I am going to get it. Is it clear? L is equal to r theta. In that fashion, 2 pi r is equal to r theta. 2 pi r is equal to r theta. So from this, theta is equal to 2 pi into small r by capital R. 2 pi into small r by capital R. Therefore, theta is equal to, sir, we are not familiar with radians, we are familiar with degrees. Therefore, we can able to write it as 360 into small r by capital R. This is also important formula, my dear friends. You try to remember. Okay, if the small r and capital R is given, if a rolling circle rolls one complete round on a directing circle, how many curves can be obtained? I will give an example for this. If small r is equal to 30, capital D is equal to 180. Capital D is equal to 180. Then how many curves can be obtained when generating circle wound around directing circle. Sir, they are not asking the angle. If a rolling circle rolls for one complete revolution on a directing circle, so it is a directing circle, sir. If it starts here, after making one revolution, once if it is reaches to this, how many curves it can able to make? 4 or 5 or 6 or 2 or 1. Very simple, sir. For one revolution, answer is correct, Twinkle. One revolution, 360 into small r by capital R. Sir, here capital D is given as 180. Therefore, small d is equal to 90. That is equal to 360 into 30 by 90 is equal to 120 degrees. Sorry, is equal to 120 degrees. Therefore, for 120 degrees, one curve we can able to get it. But for a wound, therefore 360 degrees, how many curves we will get? 3 curves. So that is the answer. 3 curves we can able to get it. That is correct. All you gave the correct answers. I will ask one more question. You try to give the answer. If small r is equal to capital R, all of you carefully observe. This is one of the most important. If small r is equal to capital R, then a P cycloid is in dash shape. Anyone? I hope few, at least one or two may drawn this particular answer in your undergraduation. I will check it out. Anybody, how many can able to give the answer? Definitely, Twinkle, I will take care because I have some sinus problem. Mostly, I will face this type of problems once if it is a raining. For last 1 week in Hyderabad, that situation is very bad. Because of that, it is. Don't worry, I will recover by tomorrow. You can able to observe. Thank you. Thank you for your concern. Now, try to give the answer for this. Anyone? I am from, my native is Andhra, but I am working in Telangana. Twinkle, answer is not correct. It is not circle. Okay, anyone? Because it is not circle. I will show this diagram. Tell me how many people were drawn this in your undergraduation. I am not expecting, but at least are you observed, my dear friends? Both circles will have the same radius. How many people in this particular room were drawn this particular shape in your undergraduation? How many people here who all are here can you able to give how many you are drawn this particular thing in your undergraduation? Are you drawn Twinkle in your undergraduation? Are you drawn this? Are you drawn this particular curve? How many people here? Frankly tell me, because even this is one of my pet question. Yeah, because most of the universities they won't give. Most of the people they won't explain this. Sri, you are not drawn this. Normally, KL University will take this type of things much more. Maybe Madhusudan sir, if he is taking, he will take that particular question. Is the pet question of him. So this is a cardiac shape. So this is one of the important, my dear friends. So they will give the options like A, straight line, B, circle, C, cardiac, D, ellipse. These are important. Don't miss this. Okay. One of the important element is this. So automatically theta is equal to 360. Yeah, you can able to say it as an apple or cardiac. So both heart shape or apple shape. Most of the textbooks they mention it as an cardiac shape, but apple is also the correct answer. Okay, my dear friends. Now, I'll ask one more question. All of you carefully observe. If small d is equal to capital R, small d is equal to capital R. First question. hypocycloid is in dash shape. Second question, hypotrochoid is in dash shape. Anyone? I'm going to give the options also. I'm going to give the options to you. So these are the options. Okay, I will keep it here. A, B, C, D. A is a straight line. I automatically C is not the correct answer because you are already aware of it. C is not the correct answer. Anyone can able to give the answer for this? How many people are drawn this one? Maybe majority you can able to draw it. It is one of the pet question for university point of view. Even remember this question we got in previous engineering services examination. This one we got it. We got this one in the previous examination. Ellipse. For first one it is ellipse or second one it is ellipse, my dear? Twinkle. Hypotrochoid is an ellipse or hypocycloid is an ellipse? I need the answer for this. My God, first one is wrong. I will show it. I will show, my dear friends, just you observe. Sir, here if you observe, in this case, all of you observe this one, my dear friends. In this case, the inside black color circle is exactly half of the radius of a outside circle. Just you observe this. Am I right or not? So here, small d, the diameter of the smaller circle is equal to radius of the directing circle. Now you observe. So the points on the circumference, green and blue are on the point on the circumference of the circle. So whenever it rolls, what is the shape we obtained? Just you observe. Green and blue can able to generate a straight line. That's why. My God. So green and blue can able to generate a straight line. All of you observe. My God, why it is not forwarding? So here the blue and green are on the points on the circumference of the circle. So whenever it is rolls, it generates a straight line. Therefore, the first one is a straight line. Sir, what about the second? Hypotrochoid. Inside point, sky blue and red, is an ellipse. Sir, we got this question in 2017. Engineering services examination. Whenever they introduced this particular subject in the engineering services, they gave this. But majority, because even I took almost 30 to 40 batches in my undergraduation classes first year. With all those cases, I used to take these two questions. My students' sheets, if you observe, they will have these two questions must and shouldly. Because one is cardiac shape, that is apple shape, or another one is straight line. Ellipse I was not made so far because trochoids were not there in our syllabi. So cycloids I made it. So now tell me, sir, they can able to ask, sir, if small r is equal to capital R by 2 or small r is equal to 2 times small r is equal to capital R or D is equal to small r. This condition, anybody knows what type of condition it is? Yeah, first one, just you observe, my dear friend. Here green color point and blue color point on the diameter endpoints of a rolling circle. Diameter endpoints of a rolling circle. Now whenever the circle is rotating, just you observe what is the shape. Green color point is generating straight line. Blue color point is also generating straight line. So this is a hypocycloid. Hypocycloid means the point is on the circumference and it rolls on a inside a circle. So it is a hypocycloid. So we got it as the shapes as a straight line. Whereas hypotrochoid, so in this diameter line, blue is on the circumference, dark blue. Sky blue is inside, red is also inside. Therefore, once the point is inside the circumference, it is called trochoid. Therefore, hypotrochoid is an ellipse. So you observe ellipse shape you obtain. Yeah, hypotrochoid. Is it clear, Vishal, now? Twinkle, is it clear now? Is it clear? Yeah. So, and next, if small r is equal to capital R by 2 or 2r is equal to 2 small r is equal to capital R or d is equal to 2r. This is called which condition? This is called Toucy couple. So whenever this condition is satisfied, then it is called Toucy couple. All of you remember, hypocycloid of a Toucy couple is an ellipse. Sorry, hypotrochoid of a Toucy couple is ellipse. Hypocycloid of a Toucy couple is a straight line. Hypocycloid of a Toucy couple is a straight line. Hypotrochoid of a Toucy couple is an ellipse. This one you try to remember. Sir, up to this, the most, whatever the elements we can able to come across for cycloids, we are already covered. Now we will move on to the next element. Sir, anybody can able to give what is a spiral? What is a spiral? Remember, my dear friends, spiral and helix I will consider as a single bunch. Single bunch. Why, sir? Why? I can't able to understand. If you observe my first table, first sheet, sir, conics I kept as a one place. Rollers, cycloids and involutes I was considered as a single because both will comes under a same category. We are tracing out the locus of a point. That point is on the curve. The point is on the rolling curve. But what about spirals and helix? Why you are combined those two into a single element entity, sir? Why you are consider those two as a single entity? Very simple, my dear friends. Very simple. What it is, sir? Spirals and helix. These two are the curves obtained by a locus of a moving point. These curves obtained from a moving point. So in the previous case, the point is fixed, but wherever that point is considered, that curve is rotating. The curve is rotating, whereas here the point is not static, it is moving. It is moving. Where it is moving, sir? It is moving on a rotating object. So the curve obtained from a moving point, which when it rolls, when it moves on a rotating object. When it moves on a rotating object, then these two curves we are going to get it. These two curves we are going to get it. Sir, what about these two, sir? What about the rotating object? What about the rotating object? So here, rotating objects we will consider two. Rotating objects we can able to consider as two. What all are they, sir? If the rotating object is one dimensional or two dimensional, then it is called spirals. If it is a three-dimensional object, then it is called helix. Is it clear to all of you, my dear friends? Now it is clear. Broadly you remember. Later I will give in detail, because with the animation also I will show it, or otherwise I will show with the help of a element. Okay, my dear friends. Is it clear? Up to this you try to remember. Just you try to inform. Yeah, good. So, sir, still just you said I understood. But what you can able to give elaborated explanation? Definitely. What it is? First of all, we'll go ahead with spiral. So for explaining this particular spiral, I will consider a straight line. Let us consider two minutes, my dear friends. I can, in order to give the more clarity, I have to show this one. Now let us consider the various positions of this particular rotating line. The line is here. I am not considering a plane. Let us consider this is a line. This is a line which is rolling over a circle. The various positions are shown here. Dotted means it is not the line. It is the various positions of this particular line. Now let us consider the point P. So this is the point P is moving towards in this direction on this line. So it is moving in this direction, but the line is rotating about this point. So assume this particular point as, what is the point it is considered? The point about which it rolls is called pole. Is called a pole. Is clear, my dear friends? All of you observe here. So I drawn the circle for my reference only, but it is not required. Okay, so a line this line is rotating about one end, about its end towards the fixed point one end. So the point about which the line or a object is rotating, one dimensional or two dimensional object is rotating, is called a pole. Let us consider the point P is moving towards the center. Then what are the various positions of it, sir? Next it can able to come to here. Is that correct or not? After one revolution, it can able to reach us to this. All of you observe the various positions of it. So if you join all these points as a smooth curve, it is called spiral. Up to this it is clear, my dear friends. You tell me later, I can able to move on to the next. So what is a spiral? If a point is moving on a straight line or a disc, sir, but why you are not considering a disc, sir? Because I can't able to show the various positions of the disc. Spider net is the correct answer. That spider net is the best example for this, and remaining also were there. I will also inform to you. Okay, good. So this is considered as a spiral. So if a point is moving on a curved if it is moving on a straight line, it is moving on a straight line or a circular object, circular disc. When the disc is rotating or a line is rotating about one point, that point is called pole. Then the path traced out by it, the path traced out by the moving point is called spiral. So whenever it is moving towards it, we are going to get like this. Whenever it is moving away from it also, we are going to get the same nature of the curve. The point about which it is rolling is called pole. The path of the curve is called spiral. Is it clear up to this? Okay, now okay, now let us consider, sir, here can able to give the examples of it, whatever. Spider net is an example, or mosquito coil. Mosquito coils will comes under this, and torsion spring. All these things will comes under the example of this. Okay, my dear friends. Now, sir, how we can able to classify the spirals, sir? The spirals are divided into two categories, my dear friends. So what all are they? One is called Archimedean spiral, another one is logarithmic spiral. Those two I will explain simultaneously. Logarithmic spiral. So what is this Archimedes spiral and logarithmic spiral? Let us consider at this position the radius, I am assuming it as R1. At this position radius is at this position radius is R2 and this is the R3. So radius is goes on reducing. So therefore mod R1 minus R2 is equal to constant. Why you are consider mod? If it is moving towards the center, R1 is greater. So remember, if it is moving towards the center, R1 is greater or R2 is less. No sir, if it is moving away from the pole, R1 will be less, R2 will be more, because it is started here, it is moving on like this. Radius is goes on increases. Therefore, on that time, R2 will be greater. That's why we are going to consider it as a mod. Then it is called Archimedean spiral. Sir, what about the logarithmic spiral? That is R1 by R2 is equal to constant. Then it is called logarithmic spiral. Is it clear to all of you, my dear friends? So I will go show with an example also, not a problem. Yeah, thank you, my dear friends. Now, sir, what is this? If it is moving with constant velocity, the example is constant velocity. Here it is a constant acceleration. Ratio is constant. Ratio is constant means for every 1 second, it is going to be increases. Then it is called constant acceleration. So constant velocity if it is moving, this is Archimedean spiral. If it is constant acceleration, it is logarithmic spiral. So if I show the diagram, you can able to get some more clarity. That's why I will show this particular thing. So these two you try to observe, my dear friends. I am hiding my image for certain time. So here if you observe these two objects. Now here in one revolution, so this is one position, sir. After one revolution, it is traveled this, here also this. So the gap here will be the same. But whereas here if you observe, in the first revolution, it is traveled this time. But in this revolution, it is less. Am I right or not? So if it is moving towards it or away from it, the gap between, because it is moving it as a acceleration mode. So here for theta, so here we are going to consider C theta. So if theta is 360 degrees, I am considering. So in 360 degrees, the distance traveled in Archimedean spiral, how much it is in the second revolution or third revolution also the same. But here in this particular 360, this is the distance traveled. After the next 7, this is here. Further it goes on increases. So that's why in Archimedean spiral, it is moving at a acceleration mode, means it goes on increases. So can you able to give the examples of them? Examples for this Archimedean spiral, just now you said that is going to be the spider net and mosquito coils or otherwise torsion spring. So how many people are aware of torsion spring? Because majority are not aware of it. So what is a torsion spring? I will explain, just you observe. So if you observe calling bells, means not electrical, mechanical calling bells, then what will happen? We are going to make it as round. Then the spring goes on tightened. Once if you press the bell, it is due to unwound of these, it is going to happen. I hope how many people are observed it or not, I don't know. Just I will show if it is available with my particular thing. How many people are observed this? How many people are observed this particular yeah. Or otherwise, are you observe the tape? because I will show. Where is this tape was? So all of you observe, my dear friends, in this, so the tape thickness is same, so once if you observe these layers are, okay, this is little bit difficult, these layers are in Archimedean spiral or mosquito coil or torsion spring, all these things will comes under here. And one more thing, how many people are aware of gramophone record? How many people are aware of gramophone record, sir? Just you tell me. There also there is an example for this. Gramophone disc. I hope you are already observed that. I will show that. My God, this size is very huge. So here if you observe, my dear friends, yeah, tape recorder Yusan, even I was not observed this one in my childhood, because in televisions only I can able to observe these things. So in olden days the gramophone records are like this. In order to listen the music, it is tape is also, once if it is wounded, the path will appear as like this. So here if you observe, there are certain lines. If I zoom it, you can able to get this particular element. If you want, I can able to show it. Otherwise, you can able to observe. These are the lines, magnetic tapes they are going to arrange. They are in example of Archimedean spiral. What about this logarithmic spiral, sir? Logarithmic spiral example is shell of a snail. Shell of a snail is going to be in logarithmic spiral. So shell of a snail is in logarithmic spiral. So these two you try to remember, my dear friends. Is it clear to all of you? So then I will move on to one more word that is most important, because we are already got this particular thing. Golden spiral. So don't think that the spiral is made up of gold, but it is having another name. So how many people here? I hope Siri, I hope you can able to give this answer, because who all are from civil engineering, they can able to give this answer. Okay, this slide, my dear friend, just to take it. Good. Now, how many people are aware of it? Golden spiral. Before moving into this, we have to know some basic information. That is a golden ratio. Don't know. Okay, thank you, Shinde. Now, how many people are aware of golden ratio? Because for civil people, it is one of the most important element. Normally, the golden ratio is going to represent with the symbol phi. It is not pi, it is phi, PHI. So what is this golden ratio, sir? So what is the advantage and what is use, I will explain later. First of all, we will know what is this golden spiral, sorry, golden ratio. So for that, let us consider if there is a line like this and you are dividing this line into two parts. This is the A portion, this is B portion. If you are dividing a line into two parts, I am not using the word equal parts. You are dividing a line into two parts such a way that the ratio between larger element to the smaller portion, larger portion to the smaller portion, if it is equal to total length to the large portion, then it is called golden ratio. If you are dividing a line into two parts such a way that the total length to the large length is equal to large length to the small length, then it is called golden ratio. Sir, how we have to get this value? Very simple. A by B is 5. Okay, sir. Now I can able to write 1 plus B by A. So A by B is 5 is equal to 1 plus B by A is going to be 1 by 5. We are going to get this equation as 5 square is equal to 5 plus 1. Therefore 5 square minus 5 minus 1 is equal to 0. I hope you know how to get this particular value from the equation. Just you remember it. Now it is not required. So if you are going to use, I hope you are already familiar. So the answer we are going to get it as 1.618. So the phi value for these we are going to get phi is equal to 1.618. 1.618. Yeah. So, sir, if it is 1.618, what is the importance of it, sir? Okay, we got golden ratio. Good. So, what is the importance of this in case of practical application where we can able to show this? Where we can able to show this? Very simple, my dear friends. So, from next, okay, after this I will explain. Now, how many people are aware of this particular? What is this shape? Just to tell me, because you are already aware of it. Every day we are observing this. What is the shape of it? What is the shape of it? Has it thrown a very difficult question? What it is? What is this shape? Maybe you are not clear with this. What is this shape? Perfect. Are you observe, my dear friends, in the villages they can able to conduct this thing also. They will ask them to break the egg by applying the force like this. Normally, most of the people they can't able to succeed because it won't break. It required more than 25 kg of force is required. Now, if you apply the force in this direction, it can able to break very easily. Even 0.5 kg of it can able to break. Why, sir? Because it obtained this much strength because of this region. So if this is the radius R2 and this is the radius R1, for the egg R1 by R2 is always equal to 5. So R1 by R2 is equal to 5. Actually, my intention is to explain egg only because I was not drawn properly. So here, why it got it, sir? Or otherwise, take an example of human body. The novel is here. Now, if you observe the distance from here to the head and head to novel and novel to foot will be the same. No, sir. This is A and this is B. A by B is also following 5. A by B is also following 5. Yeah, because practically it is there. Now, let us consider one more example here. That is my head. Many of the people. Majority I am going to give. Okay, only vegetarians can able to guess it. Now tell me what is the shape of it. If I show some duck shape or something else, you can't able to identify. Okay, not a problem. Kidding only. Now let us consider one more thing. Sir, if you observe the head, so here the radius is less. Here the radius of curvature is more. Radius of curvature here will be more and radius of curvature here will be less. So this is also in golden ratio. For getting high strength means for getting stability and aesthetic look. We are going to use golden ratio. Golden ratio is one of the most important element in structural analysis. So in structures, whenever they want to build like you can able to take an example of parliament building. They are also used this particular golden spiral element in their construction. Okay, my dear friends, is it clear to all of you? So for getting the stability and aesthetic look, we are going to use, it is going to be golden ratio. Good. Even if you type it and check it out, even Mona Lisa picture is entirely following golden ratio. Okay, now, sir, apart from this, sir, what is the relation between golden ratio and golden spiral? Before that, sir, can you able to give which number series follows golden ratio? Anyone here? Which number series follows golden ratio? Which number series follows golden ratio? Correct, that is Fibonacci series. Fibonacci series will follows. What is this, sir? 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 3, 233, 377, 610, and so on. So this is going to be considered as a Fibonacci series. So the sum of the previous two numbers can able to give the next number. Now you check it out. What is the ratio of these two? 610 by 610 divided by 377. I hope you are going to get 1.618. 377 divided by 233. We are going to get 1.618. 233 divided by 144. We are going to get it as 1.618. All of you observe, my dear friends. After this, you try to do the calculation. So Fibonacci series is following golden ratio, except first few. So up to beyond this, don't consider. From 13 onwards, it is going to follow the golden ratio. Is it clear to all of you? Sir, what is the relation between golden ratio to golden spiral? Very simple. If R1 by R2 is equal to 5, then whatever we are going to get, it is called golden spiral. Sir, how we have to get it? Let us consider, my dear friends. Here, I am considering like this. So, for example, I am considering a rectangle. With this total length. I am assuming it as 34. And before 34, how much it is? 21. This is 21. Therefore, in this rectangle, I am going to construct a square. What is the largest square possible, sir? 21 by 21. Then how much it will become? This will become, it is going to be 13. Am I right or not? 13 we are going to get. So 13 by 21. So it is 21, sir. In 13 by 21, 13 by 13 is possible. Now here it is going to be 8 by, so it is 13, it is 21. Now here it is going to be for these it is going to be 13 and it is going to be 8. So if you make 8 by 8 square matrix, then it will become 5, 3, 2, 1 like this. Otherwise, okay. Now if you take this particular point as center and if you draw the curve, if you draw the quarter circle, if you are going to draw the quarter circle like this. Now this is my center 2. With 13 as radius, I will try to draw the arc. Next, C3 as center, 8 as radius, I will draw the arc again. 5 as center, I will draw the arc again like this. So this is considered as a golden spiral. So the golden spiral is one type of, this is golden spiral. I am going to wind up. Don't worry, my dear friends. Helix I will explain tomorrow. Only 5 minutes it will take. After completing Helix, tomorrow is the one of the most important, because tomorrow class, if you can't able to understand, because I will give in detail, in depth of it. So wherever you will get the doubt, you try to raise there only. Okay. Okay. This golden spiral is one example of logarithmic spiral. Is an example of logarithmic spiral. Okay, my dear friends. Helix I will explain tomorrow. If you have any doubt up to this, you try to raise the point. And tomorrow I am going to start projections. One of the most important. If you can't able to understand this particular concept, further topics are little bit difficult. Not difficult. We can't able to attempt that also. That's why don't miss tomorrow's lecture. Okay. If you have any queries, you try to ask it now and try to follow me in the app. And I hope you asked one the detail. So you can able to contact me to this particular number. Or you can able to contact me. It is all the numbers, WhatsApp number, contact number, everything is related to this only. I have only one. And one more thing is biology.tanguturi@gradeup.co. So this is my mail ID. You can able to contact to this particular number. So if you have any queries, just you ask me now. Otherwise, we will meet tomorrow. Don't miss tomorrow's lecture. And if any of your friends are there in the group, also pass that information. Tomorrow is the most important element. So once if you miss that, it is a very, very difficult to you to understand those things. Okay, my dear friends. Thank you very much. Have a nice day. We'll meet tomorrow. Bye to all.